Hi friends, you are watching Oracle video tutorial. This is Ravindra Reddy here. Today I am going to explain about indexes in Oracle. Okay, so what are the indexes available and what are the types of indexes? So first, what is index? What is index? So it's a index is a direct location of your what you are searching. For example, if you are searching some keyword, like if you are searching some book, that book you are searching some particular chapter. What we can do, we can go to index, then which page this chapter is starting. So that is called index. Index is a route path for your searching location. Route path for your searching location. That is a common index. Same thing in database level. Whenever we are searching data from a table, the table having a huge data. If you are searching particular row, normally it will search entire table scan, that is full table scan. But if you have an index on table, easily it will directly go to that particular row ID, that is called where the row is sitting, that is row ID, then that row will be fetched very easily. So that is called indexes advantage. In your notebook, if you have an index feature, if you have index, directly you can go to index, check the page number, then you can go to your target page. If you don't have an index, you have to go to page one by one. You need to verify where your chapter available in that particular. Same thing in database level. If you have indexes on your table, the query performance will be fast. So you can get a data very fast if indexes are created in your table level. So there are different types of indexes available in Oracle. Divided as a two types. One is a simple and a composite. Simple index means creating on single column. Simple index means that index will be created on single column like this. This you can do syntax. Create index is a keyword. Index name. You can give any name. On table name. Which column you are going to create. For example, you have a salary table. There you want to create on salary column. That is, you need to mention the column. If you are creating index only one column, that is called simple index. Then composite index. Composite index means if you are creating same index on multiple columns means you have a commission and salary, two columns. You are going to create two columns. Index will be same, but you are creating on two columns. That is called composite index. Simple index will be created on single column. Composite index will be created on two columns. There are other index types, unique and non-unique. Unique and non-unique. Unique means if you have created any primary key or unique key on column, it automatically will create unique index. If you have a primary key or unique key on your table, so it automatically create your unique index. Unique means that column can contain only unique data. That column should not contain any duplicate rows. Without duplicates only, you can create an index. If you want to create a new index, you can create a new index. That is syntax. You need to specify keyword called unique. You need to specify keyword called unique. Same as index syntax only. Only the difference is you need to specify unique keyword here. But the column should not contain any duplicate rows. If the column having duplicate rows, it will throw error. You cannot create. Otherwise, if you have a primary key or unique key, it automatically will create unique index. There is one more type called non-unique index. Non-unique index. Non-unique index means that is if the column having duplicate rows, so that time it will go for non-unique index. But there non-unique index is nothing but your B-tree index, nothing but. So there again other two types indexes will be there, bitmap index and B-tree indexes. Bitmap index and B-tree. So bitmap index means is nothing but your unique. If the data is available unique, that is called bitmap. If you have a duplicate record, that is called, sorry, giving a reverse. Bitmap index is nothing but if the data is having a less cardinality. Less cardinality means there are flag related columns, true or false, like a gender, male or female. So that type of data will go for bitmap. B-tree means that is normally high cardinality. So if you have a unique data, so that time we will go for B-tree indexes. So first, what is a cardinality? Okay, what is a cardinality? So there are one more type called function-based indexes. Function-based means if you are giving any filter condition based on some function, so that time the performance will go low. So if you create a index based on your requirement, what exactly you are searching, that is called function-based indexes. So first, what is cardinality? Cardinality is nothing but depending on your data, that is number of unique rows, that is number of distinct rows divided by total number of rows. If you are getting one cardinality, that is called high cardinality. Okay, you are getting one means that is high cardinality. If high cardinality column, we will prefer B-tree indexes. If cardinality is less than 1 means that is low cardinality. That column having more duplicate rows. So that time we will go for bitmap index. Then one more thing, if you are going for bitmap indexes, that modification should be very less, frequency very less. Otherwise you will get a deadlock errors. You will get a deadlock error. Normally bitmap index preferred for data warehousing. Data warehousing, obviously you will get a duplicated data, right? History data. Most of the columns having the flags. Okay, so that time we'll prefer bitmap. Why? Because in data warehousing modification will be very less, only less modification. Transaction database, that is OLTP database, you will get a huge transactions. Daily you will go for update or some modifications on the table. Multiple users you are modifying the same table, some record, so you will get a deadlock situation. So that is called bitmap index is preferable for OLAP databases. B-tree index is preferable for OLTP databases. OLTP also you can use bitmap, but very less modifications. Otherwise you will get a deadlock error. Then this is cardinality. For example, I have a table, employee table. So this is my employee table. So in this table, there you can find employee number and employee name. Employee number is unique as well as normally this is primary key data. You can expect always or it is unique data. As well as employee name also you can expect unique. So maybe real time you can't expect always unique. Maybe same name, maybe available different employees, but ID is unique. But in this table I have all are unique. Employee name also unique. Employee ID also unique. Sorry. Employee name I have inserted twice here. So you can't create a unique index on this table. So if you try to create a unique index on this table, create unique index name, that is index ename on table name, that is ENP, column name ename. I'm trying to create index on ename, but the data is duplicate data is available. See here, align. Then see here it is throwing error. Cannot create a unique index on this column. Duplicate keys found. So there is a duplicate data in this column. You cannot create. That is the mistake. Now I can go for normal index, or you can go for any unique data. Unique data means that column having unique data, like employee number. Create unique index. So this column already indexed. Actually, that column having primary key. Primary key column will be created default index. See here, go to constant. See here, primary key is available. Primary key is nothing but it will create unique index. Primary key or unique key. But foreign key, it won't be create any unique index. So that is. Then, so this is called unique index. Then I have another table, DEPT. So here you can see location is unique, account name also unique, department number also unique. Now we can try to create unique index on this column. Create unique index, index name, location on table name DEPT, location. See, index is created. So normally, whenever you are selecting particular, see here, where location equal to, you are giving some filter condition. If you don't have indexes, the query searching will be entire table, full table scan. If you have an index, it won't go for full table scan. Directly it will go for particular record. So that is called unique index. So index advantages, directly it will go to particular row ID. So this is, you can check. See here, full table scan. Have a index created on location table. See here, you can see location, index is calling now. It is scanning only unique index, not full table scan. If you drop index, drop index, index name. Sorry. Again, this is your index name. The index dropped. Now we can go for full table scan. You can see this is full table scan. If you create a unique index, you create unique index on location table. See, this is index created. Now we can go for explain plan. Now you can see by index scanning based on row ID. Which index? Unique scan. Unique index scan. Now you can see cardinality is 1, cost also 0 for this index, total is 1 cost. So this is the way we can create unique index on if the column having unique data. If the column having duplicate data, we can go for normal index. Now we can go for creating another index. So that is, I am creating normal index. Index name on particular column. For example, here I have the employee table. Employee table I have. Okay. So there I can create normal index name on email. See, index is created. So by default index Index is nothing but your B-tree index. Oracle, so no need to specify any B-tree syntax. So default it will create as a B-tree index. What is the advantage of B-tree index? How it will work? 50-50 algorithm. That is tree. So tree means leaves and nodes algorithm. Okay, I will give one example. B-tree will be used if you have a unique data like highest cardinality. Okay, that is normal. Then how it will be searched in your data. For example, I have employee number 1 to 20. You are created B-tree index. How B-tree index will work? I am searching for select star from EMP where employee number is equal to 17. I am searching for employee number 17. So how index will be searched? Your B-tree index. So B-tree index it will divide as a nodes and leaves. First 50-50. So total 20, 20-50 means 10. It will search 10 two algorithm, that is first 50 17 is not there, then second 50 17 is available. So now it won't search in 1 to 10. Okay, then again this second one it will search again 50-50. 50-50 means 1 to 15 and 16 to 20. It will divide 50-50. Now 17 is available in second part. Now it won't search in here. Now 50-50. Now here first part 17 is available. Now directly you will get first part. So that is called B-tree algorithm will work as a tree base. Tree base means first it will go for your header. First it will go for your header. Then it will divide two parts. If left side available, again it will divide. Otherwise, if right side is available, again it will divide your tree. If again if left side is available, again it will divide. Otherwise, here again left and right. Sorry, like this. So here 1 to 20 total. 1 to 20 means here 1 to 10, 11 to 20. Again 11 to 20, again it will 50-50 means 11 to 15, 16 to 20. Again it will divide here 16 to 20. 16 to 18, 19, 20. Again it will divide 16 and 70. So this is called B-tree. B-tree algorithm will work like this. So default index will be created as a B-tree in Oracle. You no need to specify syntax as B-tree. So that is called B-tree. If you're talking about a bitmap, bitmap will be created if you have a duplicated record, that is low cardinality. Low cardinality means, for example, here you can see I have an employee table, I have a employee table, there I have a status flag, there I have a status, you can see NY, only two values, but it is repeating. So normally bitmap will go for data warehousing, voila, databases. There you will get a huge history data will be there. Then modification will be very less. Then how it will be searched? So bitmap means it will assign as a based on your row ID. See here, I am dividing Y and N. If Y is available this row, it will assign 1. Other will be 0. Again, this row ID, y is available 1. Third row ID, 1. Fourth row ID, y is not there, n is available. See here, n is available. That's why 1 and 0. Always bitmap will assign as a 1 and 0. Then, whenever you are searching for particular status y, directly it will go to where status is 1. 1 means that it will go to a particular row ID and you will get the data. So that is, this algorithm will work on dividing based on your duplicate rows, and it will get a particular row ID. So always this will be fetching from row ID. The row ID is a unique identifier in your DB level where the row is placed in your database. That's why this is bitmap index. So these are the list of indexes. How to create a bitmap index? So here we need to specify index name. Create bitmap index status on EMP. Column name is bitmap index is created. So whenever you are selecting where status equal to 1, you are getting data where status equal to 1. Now you can validate your explain plan. What is the index is using? Bitmap index. Cardinality is only 1. See. But records you are getting more than 1. But all or only value is only 1. Value is only 1. That is, but you are getting 10 rows. But the cardinality is, see here, for this only 1. That is only y value is, right? So that's why it will assign value based on row ID. If it is particular row, the value is available, it will treat as 1. Remaining values it will treat as 0. Like this. So this is for bitmap index. You need to specify bitmap syntax, then you can use this. So this is a list of indexes. So next, function based indexes. Function based indexes. For example, so if you are going using any function, select star from EMP where upper of ename equal to hello. If you are using any functions like this, okay, the index, normal index will be disabled. Normal index will be disabled. For this, you can go for function based indexes. For this, you can go for function based indexes. What we can do, for example, if you are going for job, where salesman, then what we can do, create index name as job on table EMP upper of job, like this. You need to mention whatever you are giving here. It's a normal index only, but we are giving some function. That is, we can call it function based index. Now we can go for explain plan using range is time. So function based indexes will go for range. So this is uppercase of job. If index is not available, job index. Now we can go for explain plan. See, cost is free. Table scanning is full. If index is created, now you can go for explain plan. First is to scanning range scanning by index OID, that is called function based indexes. There is a composite index. One more index is the composite index. There is one more index called composite index. Composite index is same index only, but we are creating a two column. That is create index salary commission. Index name is I'm giving like this on EMP salary comma commission. I'm creating index on two columns, salary and commission. This is, see, index is created. So creating index on two columns, that is more than one column, not only two columns, more than one column, that index we will call as composite index. So this is all the types of indexes. Simple index creating a single column, but normal index is nothing but your B-tree index. Always Oracle will create default index as B-tree index. Then composite index is nothing but creating more than one column. Create an index on more than one column. Unique index is nothing but whenever you are creating primary key or unique key, default it will be created, or you can create using unique keyword. But that column should contain only unique data. It should not contain any duplicate. Non-unique index is nothing but again normal index only. There is no other difference. Okay. Then bitmap and bit. So B-tree I already told. Whenever you are creating index, that will create as the default B-tree index. Then bitmap index, we need to specify keyword, that is creating bitmap index. When we'll go for bitmap index, like this. You have a status column or you have a huge duplicate data. That time we'll go for bitmap index. B-tree index means normally we'll go for OLTP application. Bitmap index we will go for OLAP. OLAP means data warehousing project. We will go for this. Why? Because if you are creating any bitmap index, that column is whenever you are going for updation, you will get a deadlock error. Okay, so that's why you have a less modification, less updates. Normally data warehousing will use only for analytics purpose. That's why we'll go for bitmap indexes. So this all list of indexes. If you have any still queries on regarding indexes, you can comment on my YouTube channel. I will give you more on that. Thank you for watching my videos. Okay.